Hello, yeah, in this video, I want to show you how to perform a weighted propensity score analysis. Okay, so we have seen a video on how to do matching using propensity score. And weighting is another way to use a propensity score to keep a balanced treatment versus control group and for causal analysis. So here, what we need is the library called WeightIt. Okay, load that in, and we want the package cobalt. Um, and we can load the data set Lalonde from the cobalt package. And this is what it looks like. You have the treatment variable, age, education, race, married, no degree, RE74, RE75, that's two covariates, and then RE78 is the outcome. Okay. So the first thing is we'll compute different weights using WeightIt. So the first one is we're going to use the logistic regression and use the ATT estimate. ATT means the average treatment effect on the treated. Okay, so this is the average causal effect of a treatment on the individuals who actually received the treatment. Okay, so this one, the syntax is simple. Just use WeightIt and treat, regress on age, education, no degree, married, race, RE74, RE75, data equal to Lalonde, weight, a method equal to GLM. Okay, and estimate equal to ATT, stabilize equal to false, and s dot weights equal to null, and verbals equal to true. So s dot weights is if you have sampling weights, then you can turn that on. Okay, and you can read the help documentation to learn more details about the syntax. So let's just go ahead and estimate the W1 using the logistic regression ATT estimate. Now the second group of weights are boosted regression using GBM method to estimate weights for ATE. ATE is the average treatment effect, and it's the average causal effect of a treatment across the entire population, including both treated and untreated individuals. Okay, so this is more like a population averaged, including treatment and control group. And the syntax are similar. Now method equal to GBM and estimate equal to ATE. Stabilize equal to true, so we do use stabilized weights. Verbals equal to true. Now stop dot method equal to ES dot mean. So this is a stopping criteria. So stop boosting when mean absolute standardized difference is minimal. Okay, so we want that. And it's a pretty yeah, it's pretty quick. So we estimated that. Okay, and now we want to do covariate balancing probability score method using ATT estimate. And this is the, I included the over-identified option. So the CBPS is an advanced method for estimating propensity scores that simultaneously optimize two goals. One is maximizing covariate balance between treated and control groups after weighting, and two is accurately modeling the treatment assignment mechanism, predicting treatment. So it is better than just the traditional propensity score where you just estimate the propensity score, like the assignment mechanism, and then you check a balance after you estimate the propensity score. Okay, so let's try this. Okay, so do this. Okay, and you can see it's converged, give you a bunch of information. And then the last one is the entropy balancing method. This is just another way, another criteria for balancing the groups. So you got method equal to eval, and then ATT, and we're both equal to true. Okay. All right. So we estimate the 4 types of weights, and we can check balance diagnostics for all weights using the about.tap function from cobalt. So here it's like that. Oh, this is not visualization yet. So we can use this about.table. So this is W1 n equal to true and weights equal to W1 at weights. And so here you can see the output. They give you the propensity score, the variable names, and then tell you the type of the variable. And for example, propensity score is the distance, and age is continuous, and the no degree is a binary. And then you can diff.un, so the unadjusted difference, you can see, and then the diff.weighted or diff.weights, these are after the weighting, the differences on this, the group differences on this variable. What usually you will see is the diff.un unadjusted difference is usually large, indicating unbalance between the groups. Then the diff weighted or the diff weights, and this is should be much smaller than the diff.n unadjusted. Okay, so if you look at this outcome, it's like that. Okay, so for example, the age you get diff n is negative 0.3094. And the diff weighted is 0.1188. Okay, so it's reduced a lot. And in general, we want the kind of the weight difference it, to be less than 0.2 or even less than 0.1. Okay, if it doesn't, then we need to go back to do a better balancing. Okay, so here you can see for the age variable, it's a little bit, you know, it's not it's exceed 0.1, so it's a little bit disappointing, but most of them are okay. So if we look at the next one, this is for the I think the GBM, right? And then you can see even after the weighting, you still see a lot, like the propensity score is 1.23, age is 0.28, education 0.1, and race black is 0.25, and you got 0.27 and 0.29. Oh, by the way, the positive sign and negative sign is just the balance, the direction, which we don't really care about too much here. We care about the magnitude, so you can look at the absolute value. So this one is telling us the GBM way for estimating the weights really does not do a good job. You got a lot of unbalanced covariance here. Okay, so we have to, if you want, you can go back to do a better fine tuning of the GBM model and get a better balance. Okay. Similarly, you can see this is the third one. I think it's that's the when you maximize both the balance and the treatment assignment, right? And for this one, you can see, oh, it's all very small. Okay, it's all below 0.1, so the balance is very good. So this weight is good. So the last one, the entropy one, is even better. So almost all the weighted differences are almost zeros. Okay, so for subsequent analysis, probably you want to use, you want to use the one with better balance. Okay. Okay, so next one, we want to visualize, we provide some visuals about the balance. So we use the bal.plot from the cobalt package. You can see the before after, and then you have the treatment versus the control group. The unadjusted sample, you can see there The two distributions are more different, but the adjusted one is more, the two distributions are closer. Yeah, so similarly here and here. Okay. Okay, and then we assign these weights, add them to the data set, and then we can just loading the sandwich in sandwich package for robust variance estimation. Okay, so then we can do linear regression for the using the GLM weights, and this is to say, oh, it's significant. There's significant treatment effects, and we can also use the advanced outcome modeling. And this is we are going to use the weight equal to W1, but we are going to use LM underscore weighted. Okay, so this one is actually, we're going to take into account of the fact that the propensity score and the weights are actually estimated. They're not the true parameter values, they're estimated values. And when we were estimating them, they're from the same data set, so they may have certain correlations or some other relationship that usually tends to reduce the standard errors that tend to lead to more significant results. So that's why we use the sandwich robust variance covariance estimator to adjust for inferences. As you can see here, when we use that LM underscore weighted, now the p-value for the treatment is 0.128, so it's larger than 0.05. Okay, so actually we cannot confirm a significant treatment effect using the robust sandwich variance covariance estimate. Okay, so this is kind of a very quick introduction showing you how to use the weighted package in R to perform weighted propensity score analysis. And if you read the help documentation carefully, there are a bunch of more things you can do. For example, you can do superclass, you can do missing, focal, S dot weights, and verbose. Okay, so we did the S dot weights and the verbose, but there's some other things you can specify. Um, and yeah, I think um, I hope this video is helpful for you to learn about the weighted propensity score analysis. Thanks for watching, and if you like the video, please like our video and click the button and subscribe to our learning channel. I will really appreciate your support. Thank you.